So today I'm gonna be talking about far sides of Java remote protocols. So earlier this year, I conducted a research on popular cross-process Java communications protocol and found several vulnerabilities underneath. And actually, during our research, as an outcome, 100% of the products in our research are vulnerable to at least one of the vulnerabilities which will be mentioned. So a little bit about me. I'm a researcher at Viettel Cybersecurity, a local company in Vietnam. I have a web security background, and you may have known me from the recent RC Sega on Zimbra email application show. So let's get into the talk. Java remote protocol. So what are they used for? They are mainly just simply for an application A to invoke a method on application B remotely. Like you can be under the wire on the network or from different processes. So RMI is actually a programming interface, but it's most commonly known for the GRMP protocol, which is the protocol that will facilitate the the method calls underneath. And there is also CORBA. Actually, what it stands for, I don't remember what it stands for. It's actually very long, and it isn't necessary. So yeah, you can just know it by CORBA. CORBA is a architecture. Yeah, it's it's just a different kind of protocol. And for RMI, when in Java, they are called RMI over IIOP. So there's a GRMP and IIOP protocol, and GRMP are the most commonly used one. So let's get into the RMI GRMP, which is the most widely used. The architecture is very simple. There is the client and the registry service, the custom services, and the DGC service. The registry service is basically like a naming handbook that will keep the record for all the services. Like when you want to invoke a method A, you have to connect to the registry to ask where it actually is, and to obtain the needed information to invoke the actual method. And the DGC is for garbage collection. Like it's a process in Java to clean up unnecessary resources, and the purpose of the DGC isn't relevant, but its exploit are actually quite useful, as I will detail later. So for one method to invoke a method, there will be a pair of TCP request response, and it will be the methods are mapped to a class, right? A Java class, and that Java class will be mapped to a unicast server ref with G and internal Java classes. Yeah, so that's basically it. Under the wire, it works like this. So we send the header like any other protocol, and the operation call or ping. Actually, Nmap, which is a network scanner, use the ping operation to identify the RMI service, which means like whenever you use the ping operation, the server is required to send back a response. And there will be an object ID, and every RMI services is identified by the listening TCP port and a random unique object ID, which is this. Yeah. So the TCP socket and the object ID. And next, we will send a number. The number is actually deprecated and not used anymore, but it will play a very important part in the later exploits. And there will be a method hash, which is to identify the method that we want to invoke. So to the information to invoke an actual RMI service is the TCP port, the object ID, and the target method hash. The registry and DGC services, as I mentioned earlier, are the special services with a pre-known object ID and a method hash. Object ID can be obtained from a lookup to the registry, because registry is like a handbook, right? A record keeping service. Method hash can be calculated from the method description. For example, like public void A and the arguments. Yeah, so it's pretty simple. And lastly, are the arguments. They are passed onto the wire. The server will accept the arguments and then invoke the actual methods with the mentioned arguments and then return the value. So let's guess how the arguments and the return value are marshaled under the wire. Given this is a network protocol and this is our Java. Yeah, so this is exactly what serialization for Java is built for. So there have been several research on this aspect in the past, most notably from Moritz Bedler. He published a registry exploit on 2016 and exploit unsafe deserialization on the registry and also the DGC service. There's a downside to the registry exploit in that it only works with the registry and the service port, and it has been fixed since JRE 8 U19121, which is like many years ago, 2017 or something like that. And there's also the DGC exploit, and it's also fixed in JRE 2A121, but it has an upside that it can work with every RMI service port, because you can see in the live code that the check for to fetch the RMI service, it will skip. It will return no for the socket part if the service is DGC ID. Yeah, so that basically it just skip the socket check. Cool. So how are they fixed? In Oracle introduced JEP 290 in JRE 8121. So it's a native API introduced attached to the object input stream class. For those of you who don't know, object input stream is like the method, the class that is commonly used to invoke read object on, which is another deserialization, what triggers the deserialization. So yeah, it's introduced a native API to impose a class whitelist check during deserialization. Before this, you have to use a technique called look-ahead deserialization, which you have to override the object input stream resolve class method and use a custom one that doesn't have the malicious class included. Yeah, so this JEP 290 just make it easier for the developer. And looking for the nosings, they are fixed. So there's also the registry whitelist bypass in the past. It's not it's not widely known, but it can be used to bypass this RMI registry service whitelist check. And it has also been used in several recent exploits, most notably against Oracle WebLogic T3 protocol, like in the past year, 2018. So we know argument and return value are deserialized on server side. So how about the client side? Does it get any better? So of course not. And the idea for a bypass that I'm sorry to mention that this chain has a downside that it triggers outside the deserialization flow, so you cannot actually read the RMI return value, and you have to use an external channel like HTTP or DNS or something like that. And here's my whitelist bypass. The idea is to return a an RMI server-side call into the client-side call because it doesn't have any whitelist implemented. So basically, the idea is to proxy any interface method call into during the deserialization into a proxy, an RMI proxy called Remote Object Invocation Handler that will have us invoke that interface method call on the remote side, on the server side. So basically, that it just have make a client-side RMI call. So it has the upside that it can read the return value and can be used as a data extraction channel. So here's here it is in action. There are a couple of calls at the beginning meaning the end. So this is a Java stack trace, so the beginning is actually the end. There are some dummy calls to read the gadget sync, which is a interface method call, and then I will proxy it to a remote object invocation handler, and then it will have me invoke a client-side RMI call, and at the top you can see that the read object doesn't have is invoked on an unfiltered object input stream. So this is Oracle as a response. The issue is after JEP 290, so there is a way to prevent the attacks. And they cite the document at 1 at the end of the slide. And they require users to manually configure a stream to block these chains. So yeah, they leave it to user responsibility. So we will know how other vendors are prepared for this just a bit later. So let's talk more about RMI services. There are, as you recall, I also said that there are the custom services. This is actually where the services are, the real methods is called. And it's kind of an overlooked service because I haven't seen anyone pay much attention to, oops, sorry. I haven't seen anyone pay much attention to these kind of services. So JEP 290 also states that users are required to set a filter on the input stream to block the to validate like the classes that are able to deserialize when they are in Marshall. So yeah, they are kind of leave it to the user responsibility. So let's see how vendors are likely to follow their recommendation. So the answer is none for every product in our research, including from VMware, Dell, Pivotal, and Apache. Actually, this is 100% of the products we look in. Basically, you can just Google any product that use the RMI protocol, and then you can find a vulnerability in it. It's actually that easy. But products are usually bundled with the JRE version that is larger than the 8.121, which is where JEP 290 are introduced. So it looks like they are aware of the threat, but they are taught the WSO 0, which is the initial exploit that in the past, are the only way that RMI can be exploited. So yeah, look like an overlooked attack surface indeed. Full attack still needs to change it with a gadget for something meaningful. So, but we still achieve in all of them, most of them actually. So this is exploit analysis. It's very simple if you understand the protocol. So you just send the header, the object ID, the method hash, and then you replace whatever in the arguments with the payload that you want to deserialize. So it's actually very easy. So yeah, you can just construct a Python script with the header bytes, and then append the payload at the end, and it'll work effectively. Yeah, a fun sample. So I picked VMware Virtualized Operation Manager as an example because It has a fun exploit development process in that it's kind of hard to pop a gadget out of this one. So it uses RMI extensively on port, on like 10, a dozen support. And it uses a JRE to 8.121. It has the common bin-UT gadget, but direct code execution failed because a template implement, which is a class that will help us, that you will find in most of public voice of serial or something like that, exploit gadget chains will need, because this is allow us to construct malicious bytecode from any Java getter or setter method call. So VMware blocked this in the product. So I modify a little bit into to trigger a remote GNDI a getter method call, and then use the CVE 2018-3149 LDAP GNDI remote class loading, which is actually not relevant to this talk, but it's quite handy because it's very commonly used in the exploits, deserialization exploits. So let's talk about that. Let's leave it at that, because we have many more targets at the end, many more fun targets at the end. So let's talk about JMX. JMX is a Java management protocol. It's when run remotely, it requires running over RMI. The flow is basically just like any RMI method call. It fetches first it fetches the JMX RMI record from the registry, and then it calls the RMI server implement new client as a custom service to authenticate. If successful, it forks a new RMI listener. So in the past, there have been one fix at this because Oracle didn't implement the filter for the argument string types. So it leads to arbitrary deserialization. And finally, client connects to the fork RMI service and invoke the JMX methods. The fork service they all have a random object ID, and theoretically, if one can brute force that object ID during the service time span, he can bypass authentication. So this is like security by obscurity. So if you notice, there are 3 phases to this, and they block the second phase and the third phase, and the second and the first phase, but the third phase, they did not have a filter implemented. So anyone after the authentication can achieve arbitrary deserialization, and this is under this has been reported and under disclosure. Yeah, so that's basically it. So there's one minor detail. JRE 10+ has that attribute that can you can use to specify stream whitelist, but JRE 8, which is the most widely used version, has no way to prevent this. Cool. Let's leave RMI aside and I'll talk about CORBA. CORBA under Java is RMI over IIOP. And it provides native API to unmarshal simple object structure like primitives, string, and CORBA objects. So this is because they are required to work between across different languages like C++ and Java. But since version 2 or 3, CORBA allows complex language-dependent object types. So in Java, this is smells like deserialization. So Java object is read from the stream at the input stream.read value. So it's a internal Java JRE package. But it actually doesn't use the well-known object input stream. But again, why does we need object input stream? Because we only need the mechanism to invoke the class custom read object. So this is like it works the same ways at object input stream, just that just that it needs it needs a different object types when for the class ID and things like that under the while to identify the object. So the most important part, it can invoke the custom class read object method. So as you can see from the first input stream.read value, which will trigger the deserialization, it will come down to the end at the invoke object reader, which will invoke the class custom read object method, if any, if there's one. Yeah, so again, that's a deserialization exploit. Let's talk about Websphere thing, because Websphere use this extensively on their products. So for those of you who don't know, Websphere is a very well-known web application server for enterprise products. It's from IBM. So they move on the JRE packets for the CORBA protocol from Sun into their packets at com.ibm.rmi.iop. And it actually works the same way, but it implemented a custom authentication model. So our target is to find a place, that accepts a CORBA 2.3 object. It has to be pre-authentication, and it has to be enabled by default, so that our exploit has some value to it. So we dig into every flow of the CORBA protocol, and we find out that the interceptor as server request interceptor at the class will be invoked right before every method call, RMI method call, and because it's actually invoked before any of the method call, so there's no authentication involved, because the authentication took place in the RMI method call. For Websphere, there's one interceptor. Its name is TX server interceptor, and it's also available in Wi-Fi and Red Hat EAP, which is the same kind of thing. Red Hat EAP is Red Hat enterprise application products. It's actually also vulnerable. They are also all vulnerable to the same kind. But let's talk about that later. So for IBM, a TX server interceptor, so it accepts basically it just accepts some data for its business purposes. And then it passed right into the demarshal method, so which will eventually invoke a read any on the input stream, and a read on any will lead to a read value, which will lead to the deserialization. And we still need to find a suitable gadget to escalate it into something meaningful. IBM CORBA is actually very hardened. They removed the silent template implement serializable capability completely. As I mentioned earlier, the templates implement is required for the most publicly available gadget chains to work. So it's kind of hard to pop an RC gadget chain out of this, and it's also have a very strict class loader. But still, IBM is a huge product, because it's an enterprise application. So we found several interesting gadgets, and all of these are still. I didn't want to disclose any of this because it's still under disclosure, but I will give a demo. So I have an access to library writing to an arbitrary file. But unfortunately, it doesn't work with GSP web shell, so you can use it to, for example, override etc password and make the system unusable. Because Websphere by default must run under the highest user, as documented by IBM, and many accesses, so it can lead to local file disclosure. And finally, a gadget to lower an arbitrary class under the file URL. Since it's a file URL, we have no way to pop a to like inject an HTTP URL into it. So we have to use a trick, which is under Windows, we can use a UNC file path to denote a remote file share, which can lead to remote class loading. So let's move to the demo. Yeah. So this is on your right-hand side. This is an IBM installation, a fresh installation. It has a process explorer here. You can see that there's only the Java process, which is of IBM. There's a bunch of ports which IBM listen on, and inside there will be like the 2809 and the 94022 to 9403 and 9100. So which all can be popped via the CORBA exploit. Yeah. So this is to prove that this is the latest build available. This is built on August the 28th this year. So this is the latest version. All right, so here's the exploit. So this is a in-packet, the in-packet SMB server to fetch an SMB server to deliver the payload. And this is actually the exploit running in the background. And as you can see here, the java.exe of the IBM process actually pop a cow here, a cow.exe, which is what our payload does. And the cow is run under anti-authority system, so it has the highest privilege. So it's like a CVS 10.0. So that's for IBM. Oh, cool, thanks. So vendors are not prepared for this, because in the code for the IIOP input stream, the resolve class, which is normally used as for the look-ahead deserialization mechanism, it is explicitly state that the method resolve class is not supported, and it throws at an IO exception. So there can be no way the look-ahead deserialization can be used in this case. And JEP 290 also does not provide any filter API for the input stream. So there's no way for now. There's no way that one can prevent this without like touching into the internal API of the package. So cool. Let's moving on. There's also the security manager. So CORBA have a characteristic, a feature, you could say a feature that you can load a remote class when the input stream deserializes a CORBA native object. A CORBA native object, it's not a Java object. It's a CORBA an object that identifies for CORBA protocol. It's kind of difficult to understand, but it's just you can just like think of it as a unit for the CORBA protocol. Yeah, because it's not necessary anyway. Yeah, so you can in the code you can see that if there is a security manager. If the security manager is no, which is there's no security measures, it will use the normal class loader. But if there is one, it will continue to look up, pass into the lookup loader the URLs, and the lookup loader will use a URL class loader and the whiles are under our control. The arguments are under our control. So this technique has been disclosed by Paul Tester at Black Hat 16, and he used a different attack vector, but we can combine this with the deserialization aspect to achieve co-execution by if a security manager is implemented and it's not secure enough. So a permission for security manager that allows us for RCE looks like this. So it's like permit outbound socket connection. Yeah, so that's for the CORBA and the so that's for the CORBA and the deserialization exploits. So let's talk more about the model, the RMI model. So in RMI, you notice that there has to be the registry. You have to look up the registry to actually obtain the necessary information about the service. What if we can attack the registry itself? The registry operation actually provides many useful methods for an attacker that can be used for exploits. The most interesting of one is the rebind method. So basically, it rebinds a current record into another record that can also be under the attacker control. So, so this is a new attack vector. It can allow us to man in the middle between the client and the server without any of the LAN factor. Like you don't have to approach the client or something like that. You just have to do a remote method call onto the server and rebind the record into another object under our control. So the server will forward all connection into the server under our control. And this is fully transparent. The client doesn't know it's being eavesdropped. So what do we gain from this? GMX, remember GMX is a Java management protocol, and it's based on authentication. So if we can have the GMX credentials, it will, in most cases, lead to RCE, because GMX expose very sensitive methods. So there's also many sensitive info for custom RMI service. So for example, Websphere data protection, which is of VMware, also pass credentials over the wire. But there's one thing: the dispatcher, the registry, it stands between the registry and the method call. It has a protection that will only limit the incoming socket connection to the bindable interface, which means local. So this poor architecture could already be a flaw, because if one can have a local connection, it can be used to, like for example, escalate privilege. So, but there is also some one-days and features that can help us with this. So there in JRE 8202, there's the code does not enforce the flow between like the registry and the method call. So you can force the flow into another like if branch, and it will execute the method directly without throwing the exception that the socket is not coming from localhost. So the previous scenario can now be exploited remotely. And this is this actually has been discovered several months earlier as CV 26884. But from the CV description, and they were using it for a different attack vector, which is a sandbox escape, not related to this exploit. And there's also another feature, cool feature, which is RMI GRMP allows proxying over HTTP. And when it does that, the address of the peer becomes 000, which is can also mean localhost. So yeah, but again, this has been discovered earlier by Moritz Beller, And the attack scenario he described is not related to this. It's a client-side, cross-site request forgery exploit, not related to this. So let's dig into the exploit analysis. So this is a legitimate client, the registry, and the attacker and the legitimate service. First, the attacker called the registry, and it changed the GMX RMI record into from the legit service into the attacker rogue service. Then when the legitimate client asks for the GMX RMI service, it will be redirected to the attacker rogue service. And then the legit client will pass the credentials to the attacker, and then the attacker can have his privilege. And the vulnerability pattern is very simple. This is actually the most widely common way to create an RMI registry, as stated by the Oracle document. So, in a way, Oracle is kind of not prepared for this. So, well, what can we do about it? To pop from this to RCE, there's several ways. First, if the credential have create MLET privilege, which is unlikely, then he can use the MLET ambient to load a remote class, but it's not very likely in the wild. But when there's a read-write privilege, which is the most common use, you can manipulate existing available ambients to like play with it to make it have undesired method call. So, yeah, we can also make clients deserialize arbitrary data, but it's not actually very useful in reality. So there's Tomcat. Tomcat have a GMX, remote lifecycle listener enabled, but it's actually not by default. It's a cool exploit. We can modify the abstract access controller valve to log pattern to an access log to log every our wanted header. So in this case, we can log the header pound. That pattern meaning to log every HTTP request with the header pound. And then when the attacker invoke a request with that header pound, and later invoke a access controller valve dot rotate, it will write into the specified location by an attacker with the payload at the header pound. So yeah, it's also very simple. So let's dig into the demo for Tomcat. Sorry. Okay, cool. It doesn't allow full screen. So yeah, so basically on the right-hand side, you have a Tomcat installation with that feature enabled. So this is when an administrator come into the Tomcat instance and then use the JConsole to monitor the Tomcat instance. Yeah, so this is like, it works normally. So this is the right-hand side is our exploit. Yeah, so basically I rebind the GMX RMI record into a service under my control. And then when the attacker log in again, the admin log in again. So yeah, where you have the administrator password printout right here. And he's actually authenticating into the rogue service. Yeah. So explained earlier, we can use that to gain RCE. Yeah, so this is like the final exploit to invoke a web shell. Yeah, so there's a cow pop-up on the Tomcat instance. Yeah, so we took over the Tomcat instance. We can take over the Tomcat instance with this exploit. Cool. Oracle is also not prepared for this scenario. Because the simplest fix is to use the internal API package to prevent the registry modification. But the API is package private, which means the developer can just simply use it. He have to use Reflections API or to pop into you manipulate the internal packet to make it accessible. So moving on, there's also the CORBA naming service. So it actually works kind of like the RMI Registry service for the RMI over GRMP protocol, but it has no associate involved. So applications using CORBA have to implement its own authentication mechanism. So to check, it has to check for authentication before every sensitive method call. And yeah, again, there's no product that actually uses this besides one, IBM Websphere, because Websphere accidentally uses, I believe, because they repackaged the CORBA protocol in the Sun pack, the JRE packet, into their old protocol to implement a custom authentication purpose, which isn't targeted to this specific scenario, I believe. But the others like Wi-Fi, GBox, EAP is still vulnerable. So the idea is simple. We just wrap the rebind the record into the our wanted record into for a CORBA object, which has the delegate, which will be delegate into a address under our control, and it will connect, instead of connect to the legitimate service, it will connect to our service. Yeah, so that's every attack vector on the protocol. So mitigations right now, extensive review on the RMI services for the deserialization filter construction. This is JEP 290, and keep an eye out for vendor parts for the CORBA deserialization, because there is there's no way to prevent that right now. Maybe limit connections from external client to that file under the network layer. Then you have to also review application model to minimize the design risk. This is not let the credential file over the plain text under this protocol, and keep GRE updated. And there's also a lot of room for improvements on the exploit development, because especially the gadgets. The IBM Websphere gadgets I demo earlier only works for Windows, and you can also work on much more product research. Yeah, and that's all my presentation. Thank you. Yeah, if there's any question from the audience. Sorry?
Hi, nice presentation. Thanks very much. Yeah, do you want to talk about the disclosure process you went through with the vendors?
Yeah, there are many complications with the disclosure process for this one. I try to disclose as many as I can, but there's still some that I haven't disclosed yet. Because this is actually, you can, if you understand it, is an attack on the protocol, and it's not the vendor's fault. And I don't think that the vendors, I I want from this presentation, I want the vendors to like update on the vendors on their knowledge on the RMI protocol, and then they all can do that themselves on their implementation. And as I said earlier, 100% of the products I look into are vulnerable, so I believe there's a lot more that have still not been discovered. Yeah. Cool. So I guess that's it. OK, thank you all for being here. It's very nice of you. Thank you.